Learning to program, the first thing that we learn is how to produce output to the screen. So in this first lesson, you're going to practice output strings, which is text, output numbers, output a combination of strings and numbers, output using variables. You're going to learn something that is called the escape sequences. And in Python, we have something that is called the separator, and we're going to practice that at the end. In our textbook, we have an introduction where it says that we have different levels of programming languages. The other day, we were learning about the binary numeric system and the machine language. Machine language is the lowest level of programming you could have because it's the closest to the way the machine works. We use Python, which is a high-level programming language. In Python, you're going to have different objects available. We're going to be using something that is called the shell, where you're going to see the output that is produced by the programs that you work. So we're going to start by practicing using the shell, and then we're going to use the code editor, which is another form of learning how to code. Today you want to learn by practicing with me, so please make sure that you code as I code each one of the following programs. Open idle, and what you're going to do, the first thing that opens up is called the shell, and here you could practice one line of code at a time to see if it works properly. So if we spell out print, and you have to be careful about spelling it exactly the same way, and then open parentheses and a word surrounded by single quotes, once that you press enter, you're going to see the outcome of operating that line. So working in the shell is nice for one line of code that you want to test and see if it's working properly, if it is written correctly. But normally we want to save a whole bunch of lines in a program, and we do that by opening what is called the code editor. So what you're going to do now is you're going to click at the top of idle where you read the file command, and once that you click there, you're going to see new file, and that's what you want to do to get a clean canvas, sort of speaking. So file at the top, new file, and opens this clean screen. So we're going to type the same line of code that we had before, print, open parentheses, single quote, a greeting such as aloha, close parentheses, and we can have multiple lines of code. So we're going to add another output statement, print in single quote, this is my first Python program, close single quote, close parentheses. And now what we need to do is run this program. So we go to the run command. It's going to tell us that we need to save this in a file. So pay attention to the name of the file that you assign, and pay attention at the location where it's going to be saved so you can find it later and edit it. If you're working in the same section, notice that it's going to update the lines of code just like when you continue to save. You run it and you see the output, the two lines of output in the shell screen. So when we put single quote around some text, what we are displaying is called a string. But sometimes we want to work with numbers, and when we want to work with numbers, we do not use the single quote around. Sometimes we want to display the result of a calculation that will be a number as well. So we're going to see how we can differentiate each one of those. So let's start by displaying a number. If I want to display a number, rather than putting quotations around, I'm going to simply put the number inside the parentheses without any symbols around. This text that is in red is what we call a comment. It's something that is used to explain the program, but it doesn't uh, execute, it doesn't do anything. So we type in print 5 in parentheses, run that. If this is a new file, you're going to have to assign the name again. If you're editing the previous program, you do not need to rename it. And when you run it, you see 5 in blue in the shell. See? So not putting any symbols around a numeric value allows you to see that number as output on the screen. We can put a calculation inside the parentheses. So I can say, for example, display the result of 5 plus 10. Since I do not have any symbols around the 5 and the 10, it performs the mathematical calculation. So it shows me 15 rather than 5 plus 10, it shows me the result of that. If I wanted to see 5 plus 10 as a sequence of characters, I would have to put single quote around it. So we're going to practice that so you see the difference. So this line that we typed before displayed the result of the addition of the two numbers. You can practice typing comments as well so you see that they don't show up in the output. So let's see what happens if we indeed put the single quote around that addition. Type the command line, print, open parentheses, single quote, 5 plus 10, close the single quote, close the parentheses, and now let's run this baby. We need to save it every time, and now when it runs, you see the two lines of code executes. The first one still shows 15, the second one shows 5 plus 10. So the first line of code performs the addition, so it's a numeric result what we see. The second line of code displays the text, the string, the sequence of characters, the digit 5, the plus, the digit 1, the digit 0. So without single quote, we see the result. With single quote around, we see exactly the characters that we type within those single quotes, and that's what we call a string. Let's do another example. Now instead of an addition, we're going to do a multiplication. So type the command line print, open parentheses, single quote, the number 10 plus, times, which is the asterisk. You find the asterisk above the number 8, shift 8. 10 times 2 equals, and in the next line, print, open parentheses, and the same calculation but without the single quote. So what is this going to do? The one that shows up in green in our screen is going to show up as that sequence of characters, and the other one is going to be calculated. Now the previous lines of code, they're still going to be performing because we kept them there. So you see that it says restart in the output, and you have 15, then the addition, then the multiplication, equals, and then the 20. So sometimes what we want to do is add some string that serves as a divider in the different things that we do in a program. So I'm going to give you that example now. So I'm going to say print, open parentheses, and then you can use any kind of symbols that you find nice, appealing to your style and the word example. In my case, you can use different exercise numbers if you wanted to, if this was homework. And then when you run it in the output, you have a separation between the the addition that we did and then the multiplication that we practiced as another example. I did that so you could see how to multiply. The previous example was interesting, however, the output may have been a little bit confusing. So sometimes we want to combine the label and the output in the same line, and we're going to see how to do that in this next exercise. So we're going to start again so you can you can delete the command lines that you have in your file and start again. And we're going to combine text and a number in the same line. So we know that the string is going to show up in the screen as we spell it out. So print single quote 5/2 equals and close the single quote. And if we put a comma, we can output something different afterwards. The next item is 5/2, which is the division of those 5 divided by 2. And when we run it, we're going to see 5 divided by 2 equals, and in the same line you see 2.5, the result of the calculation. So this is much more user-friendly as output when you have the label and the result both on the same line compared to what we were doing before. The exercise we were working on before has a little bit of a problem. If we wanted to use the result of that calculation further into the program, we wouldn't be able to use it because we're not saving it. We're not storing into any variable, any location in memory. So what we need to do normally is to use something that is called variables, and sometimes we use constants as well. So a variable is something that we create so we can hold a value under a certain name, and instead of using the value after we have assigned a value to that variable, we can start using that value by referencing the name. So in this exercise, you're going to create a variable called x, a y, and a result. So x is 3, so x equals 3, y equals 10, result equals the result of our calculation. So y times x. So we multiply those two, and now we can display the result by using the name result, and make sure you spell things correctly so then you don't make mistakes when you try to use them. So we're going to have a string output to the screen that reads result is, so you put that in quotation marks, then a comma to separate it from the value. And instead of typing in the value yourself or the calculation there yourself, you use the name of the variable. When we run it, we're going to have the same effect. You see the label result is and the result itself. But the nice thing about this is that now if I wanted to calculate the average of the two values, I can divide that 30 by 2 by saying result/2, and it's going to be the calculated result. Now we're going to practice something that makes the output look a little bit more organized sometimes, or sometimes we want to display special characters that have special meanings. So we need to play a little trick on the programming language so we can display those characters, such as, for example, if we wanted to display the quotation marks on the screen or the single quote because it has a special meaning, we need to escape from that meaning. So for that reason, we have character sequences such as \t, \n, \quotation, \single quote, and we're going to see I'm also using \/ later on. So let's spell out the different numeric systems that we are familiar with in an output string, and we see the output. We can always use copy and paste like in any other text editor program with Control C, Control V. And in between each one of the names of the numeric systems, we're going to insert the characters \T as in Tom. When we run it, we're going to see that the output is going to look slightly different for the second line of code compared to the first one. So we know the first one displays binary, octal, decimal, hexadecimal. The second one will do the same, but insert \T between each one of the names and then run it and see what happens. There you go. You see that a tab was inserted. So when you use \T, T is for tab. So it allows you to organize otherwise text-driven output. It allows you to organize it in columns if you needed to create a table with your program. So now I copied and pasted the one that already has the escape sequences, and I replace the T with another symbol. I'm going to replace the T with an N, as in Nancy. So we run it with those 3 lines of code, and 3 lines will execute. The first 2 are going to be like before, and now you see that binary, octal, decimal, and hexadecimal, they're spelled out one below the other. So I have one line of output statement, one output statement, but 4 different lines with the output, and that was accomplished by inserting the \N between the words. And now we're going to practice showing if I wanted to see \N sends the cursor to the next line, then to display the backslash, I need to put a backslash in front. So I change the meaning of the backslash. I make the program snap out of the meaning of the backslash. So \N sends the cursor to the next line, and there you see the output. So \N displays \N rather than actually sending the cursor to the next line. I need to do the same if I want to display quotation marks or if I want to display single quote. So in this example, I'm using \single quote and then F and then \single quote. So that is going to make the program display an uppercase F surrounded by single quotes. Since the single quote is the one that is used to represent the strings that I want to output to the screen, when I want to display the single quote, I need to put an escape sequence or an escape symbol in front. So see, now in the output, we see F surrounded by single quotes and the rest of the text. And now we're going to see how we can use backslash to display a quotation mark. So now I'm going to use backslash quotation. So that's going to display an uppercase surrounded by quotation mark. And I'm going to see A is my goal for this class, but the A is going to have quotation mark around. There you go. So there is the final output statement for this program that uses the escape sequence to display the quotation mark. So those are the escape sequences. You have \T for tab, \N for next line, backslash to display the backslash on the screen, and \quotation, single quotes. Finally, something cosmetic that we can do for our output is to have a special character or multiple spaces that are used to separate multiple values that you display to the screen. So I'm going to have an example here for us to practice together for the binary numeric system. So if you have a bunch of zeros and ones, it's normally a good idea to separate them with some kind of vertical line. So we start a new program. We start blank and we declare a variable for on and a variable for off. So on is 1, off is 0. So on equals 1, off equals 0. And now I'm going to display to the screen, so print, open parentheses, and these are variables, so we just spell out the name. So we need to separate them with commas. So on, off, on, off, on, and you can stop at the second on because I count them and I realize I went one too far. And now we spell out SEP for separator equals, and then whatever symbol you put next, surrounded by single quotes, is going to separate the variable values that you are displaying. So you could have a comma with a space, a tab, whatever you want. There you go. So when I output that, because the variables on and off represent 1 and 0, they're replaced by the values, and the separator is displayed on the screen. So this is used for cosmetic reasons, and it helps you when you have to output multiple values. You can just say once what the separator is. A lot of times we use a comma to separate values. In this case, I chose something different because of the zeros and the ones. I hope you like this and practice so you can remember this.